Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we're going to be talking about geometric vectors, right? So this is the first video on vectors, guys, so let's go ahead and get started, right? So first of all, what I'm going to do is I'm actually going to define what vectors are. So before we do that, we're actually going to define what is the need for vectors, right? So I'm actually going to talk about the need for vectors. So let's say, for example, that you want to talk about, let's suppose you want to talk about there is this point here. Let's suppose this is this point A, right? And on the horizon, this is where the point A exists. Now, what I do here is I actually move the point A 10 units to the right. If I move the point A 10 units and I bring this point A here, let's suppose this is the new location of A. Let's say this is AN. Now, if I were to talk about this mathematically, I would say that point A has shifted. So I would say that point A has shifted by 10 units. This is something that I would say. However, 10 units can be in either direction. Point A can move 10 units in this direction, in this direction, or in this direction, or in this direction. Or let's say even in this direction, or even in this direction. So that tells me infinite number of ways in which point A can move. So how are we going to define in which, where has point A gone? So till now we were only dealing with scalar quantities. Now what are scalar quantities? Scalar quantities are the quantities which have only magnitude associated with it. Let's say, for example, distance. Right? So let's say, for example, distance is something which is scalar. You always say, you know what, I traveled 50 kilometers. If you don't assign any direction to it, well, that will remain a scalar quantity. Now, another example would be speed. Speed is something which is scalar. Let's say you travel at 5 meters per second, but you do not tell in which direction you travel 5 meters per second. There is a possibility that you travel 50 kilometers and still reach the same point. That means technically you haven't traveled at all. However, you have traveled 50 kilometers. So these scalar quantities are unable to explain the real-time examples, those vector quantities which I would like to say. So this is why we introduce vector quantities. Vector quantities are the quantities which have a magnitude as well as a direction associated with it. So they have magnitude as well as a direction associated with it. Right? Let's say, for example, if I want to talk about one of the biggest examples that I will use is of displacement, the concept of displacement. And displacement is something which is actually a vector, isn't it? So displacement is something which is actually a vector. For example, let's suppose on the horizon you are here, right? And you move to the right by 10 units. So you will be able to say that A moved by 10 units and towards east, isn't it? Right? So A moved 10 units east. So this is something which is a vector. So this is something that we call a vector. So a vector is defined by both direction as well as a magnitude. Now, what do you mean by a geometric vector? So geometric vector is represented by, so geometric vector is just like a vector. It's represented by, so let's suppose you go from A to point B. It's represented by A, B, and a line and an arrow at the top. So this is something which represents a geometric vector, right? So mathematically it would be A and B, and this would be the direction in which A and B, A is towards B. So geometric vectors are usually used in physics, even though we're talking about mathematics here. However, mostly geometric vectors are something that are used in physics because it's so convenient for us to explain concepts which are there in the real-time world, such as velocity, acceleration, which possess magnitude as well as direction. Right? So for all these quantities which are vectors, such as force or let's say acceleration, so how do we denote them? We just denote them by putting an arrow on the top. We said this is a force and this is an acceleration because this is something which is a vector. So what is the meaning of vector AB? So let's suppose if I represent vector AB, right? So this is something which can be represented as B relative of A something which can be represented as B relative of A, or the displacement of A from B. So this is something which can be represented as B relative of A, or the displacement of A from B. So this is something that we call AB vector as. Similarly, if I talk about the BA vector, the BA vector would represent A relative of B, or the displacement of B from A. So let's suppose if you're here and you travel to this direction, and then you travel to this direction, you travel at 90 degrees here, and you reach this point B. That means AB will represent this direction. So this direction would represent AB, and BA would represent this direction, so BA would represent this direction. So as you can see that AB and BA are same in magnitude, they are same in magnitude, however, they are different in direction. So they are same in magnitude, however, they are very different in direction. So I hope you're getting this point here, guys. So that's actually very easy. So AB and BA are one of the same vectors, it's just that they are different in direction. So in this case, what we'll say is that AB and BA are opposite vectors of each other. So this is these kind of vectors, we call them opposite vectors. Fine. So we call them opposite vectors. Fine. So that's what we call them. Now let's move forward to the next point. Let's talk about when the vectors are equal. So when are two vectors considered equal? So let's suppose if I have two vectors, vectors AB and let's say vector CD. These two vectors are considered equal if and only if their magnitude is equal and their direction is equal. So these vectors are considered equal if and only if their magnitude is equal and their direction is equal. So then only these vectors would be considered equal. Let's say, for example, if I have a rectangle, let's suppose if I talk about a rectangle, so in a rectangle you have four vectors, right? So if I say this is a rectangle, then you have four vectors. Let's say this is A, B, C, D. So vector AB is actually equal to vector DC, isn't it? Because they have the same direction and they have the same length. Similarly, you can say that vector AD is equal to vector BC. However, vector AB is the opposite of vector CD, because AB is in this direction and CD is in this direction. So this is how you actually represent vectors, right? So this is how you call them vectors. Fine. So now let's talk about a special case. I'm going to talk about a special case of null vector or zero vector. So what do you mean by a null vector? Or this is something which is also known as a zero vector. So what is a null vector? A null vector is represented like this, AA, which actually represents just a single point, isn't it? Because the distance from A to A, so let's suppose that this is point A, the distance from A to A is going to be a point and it's not going to have any direction. So this is the vector, this is the only vector which has a magnitude of 0. So this is the only vector which has a magnitude of 0, and this has no defined direction as well, and it just represents one point. Fine. Now let's talk about another definition of so this is something which is called a zero vector. Now let's talk about a trivial and non-trivial vector, right? So what do you mean by a non-trivial vector? A non-trivial vector is, so what do you mean by a non-trivial vector? A non-trivial vector is a vector which has magnitude greater than 0, right? So which has a magnitude of greater than 0. If the magnitude is equal to 0, then that vector would be called a trivial vector, right? So as you can see, that 0 vector is actually a trivial vector. Fine, so that is something that we have done. So let's say we pick up let's say we draw an octagon. So this is how you actually, let's say we draw an hexagon for example, right? So we have these points A, B, C, D, E, F. Now, as you can see that the vector AB is actually equal to the vector ED, something that you can clearly see here. The vector AB is equal to vector ED because they have the same direction and they have the same magnitude because they have the, the length is same as well as the direction is same. Fine. So in that case, vector AF will be equal to vector CD because they have the same direction and they have the same magnitude. However, vector BC would be the opposite of vector FE because, I'm sorry, vector EF. It would be the opposite of vector EF because this is the direction of BC and this is the direction of EF. So they are going to be opposites of each other. Fine. So that is what the definition of these vectors are. Now, thank you very much for watching this video, guys. So this video which explained you what the definition of vectors are. In the next video, we're going to be talking about basic operations with vectors. Right, so we'll actually go ahead and get started with that video. So thank you very much for watching this video, guys. Make sure that you give us your valuable like on this Facebook page and explore our website and give your valuable feedback on this email address. So thank you very much for watching this video, guys. I'll see you in the next one.